Blackboard. All right. If you want to talk about that stuff offline, I'm more than happy to go into like game generation and things of that nature. Kind of outside the scope of software engineering, unfortunately. But more than happy to chat. I'm actually running computer graphics next semester too, so probably get more graphical roguelike stuff if anybody's interested in that class. I think it's undergrad level. But a couple of things for you all today. So when you go to the Blackboard page, there is now an upcoming deadlines. Initially trying to use paint in place tiles. Yeah, there's a lot of methods you could use. Not to go too far off on a tangent, I started playing around this is fun for me, so you all get inflicted with it. I started playing around with Perlin noise for procedural generation. So basically generating kind of a noise function and turning it into graphics. So this is just randomly generating like continuous noise and assigning a tile to it. So you look at this could be like grass, water, or snow or something, right? But I took that and I applied it to my little roguelike game I've been working on. And here we have a grass barrier and maybe dirt or desert or something like that. And any of those procedural generation things can be quite interesting. Also, there's collision detection, and I made the inputs a lot nicer. So you can go diagonally, but it's not, you're zooming off the screen. My fun for today. Function to grab the specific color. Yeah, I'll have to get back to you on that one later on. I know you can read the color value from a tile. Pixel-based read the color, but I don't remember what it is offhand. Anyway, for those of you not doing video games for your project, or I guess for everybody, I added a new item to your homepage. So this is O2. We want to be O1, obviously. You guys are O1. You all are O1. Course information, upcoming deadlines. So I'm going to start listing out all of your upcoming things. First thing you see when you log in. You obviously still have the calendar. All of the assignments are still going to be in the same place. But I'm going to try to bullet them out for you all just to keep it on top of your collective radars. This is something I'm going to have to do manually. So if I forget something and you notice it, please let me know and I will rectify that immediately. But I just want another, based on your feedback, I'm trying to help out with that. So hopefully this is helpful too. So upcoming, you have your homework 3. I've had a bunch of people pop in off SARS and ask me questions. If you are uncertain or you're uncomfortable or you just want some feedback or advice, please feel free to let me know. I am more than happy to chat about these with you. Let's do Friday. Again, make sure you follow the directions, that you have everything in place that you need to. Read your lab manual carefully, and you should be fine more or less. Then at the end of the month, we will have our midterm presentations and deliverables. So that'll be the 28th and the 30th. Things that you're going to have to do, I'll give you again a formal write-up of what I'm expecting here pretty soon. Plan on having a list of tasks. So basically, we've kind of been talking about project planning, cost estimation, things like that, right? That's going to be your next assignment, which will go out after your things due on Friday, basically. Interestingly, it's going to be one of the things you have to talk about for your midterm. So it's all going to be tied together. And again, I'm going to be looking for like a short little demo. I'll look for you to talk about your artifacts and things like that. And for those of you who are struggling with planning out your semester, this next homework should help with that as well. And it's going to be one more thing that you have to talk about for the midterm stuff. And I'm not trying to sell this as like a massive pain in the butt for you all. It's more, you already have everything. You just need to talk about it. That's all. So that is Blackboard. I need to talk to some people in the student affairs division before I move forward with my next kind of hidden agenda, but I want to give you all a way to chat as well in the class. So I've got a couple of FERPA related things I need to hammer out with them. So I know in the surveys there was not everybody, but a small group wanted to actually have a voice conversation, and I would like to enable that because that's definitely a good way to chat. Um, just be patient on that one. I'm trying to make sure we don't get into any weird legal troubles with that, which is something I never thought I'd have to consider when teaching. But here we are in the era of COVID. So, this is where we left off last time. And the plan for today is basically we're going to get through the rest of these slides. We're going to start talking about actual project estimation, some of the different ways that you can figure out cost and effort. It's going to be a little hand wavy, obviously a little high level because we're not in a real business, right? A real world environment, but you'll get an idea of how these things can be done. So that's the plan for today. And Friday, we'll probably wrap up all the management stuff and hopefully look at some tools that are out there that we can play with. Alrighty, so moving right along, this is the figure that I left us off at, and I didn't really talk about it, but I said this is basically a view of uncertainty. So this is called the cone of uncertainty. It's a real thing. Very busy figure, kind of hard to read. There's a lot of moving pieces here. But the main points are that the x-axis, this is your phases of your project, right? So which stage are you at? And again, process dependent, obviously, right? This could be a loop or a waterfall. And on the y-axis here, this is going to be the amount of uncertainty in your estimation. So it's not really spelled out well in the chart here. So 4x would be that you basically have 4 times the amount of variability in your estimation. And the way you read this is that these lines basically represent uncertainty. And it works either you have a ton of variability or you basically are getting into, you basically run the gamut of variability. So X would be perfect cost estimate, right? So everything's good along the main line here. If you go too high, so your estimates are too high or they're too low. And then they basically kind of logarithmically go towards zero, right? And the way you read this, yeah, absolutely generalized. Absolutely, yeah. So how much uncertainty you can expect. And to me, if this graph starts making sense, um, early on, there's a ton of uncertainty, right? We don't know how things are going to shake out. We don't know. There's a lot that we don't know, right? Are there tasks that we're missing? Are there personnel problems cropping up? Are there customer issues, right? There's just, at the very outset of a project, you're just trying to get kind of a good picture of what efforts you're going to have to expend. And the further down the line you get, that uncertainty goes down. And I'm showing you this map in terms of like knowledge and information, right? So it's very generalized. The thing to consider though is that information management is actually an entire field of mathematics, which is kind of interesting. How much uncertainty you have in your data sets or in your process. This is actually a field of study, which dovetails kind of nicely with software engineering. So we have a figure like this, and apparently my family turned the heat on upstairs, so this room is now boiling all of a sudden. But basically we have uncertainty going down over time, right? And keep in mind, this could be cyclical, spiral or agile or something like that. But the point is over time, uncertainty goes down. Now the question for you, let's say that we get to the point where a customer has the software, they like it, they've accepted it, requirements are set in stone, everything's good. Is there still uncertainty in our project, or sorry, in our estimates? And if you're unclear about what I'm asking for in terms of uncertainty, this is in the project manager effort estimation level, right? So how many people do we need? How much will it cost? How much time will this take? Do we still have uncertainty in our estimates if we're at this point later on? Very little to none. It is smaller, right? I will give you that. However, let me try this out and see if we can get a non-blur. Of course. Where is zoom? Zoom, 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 zoom. There is some, right? Very little to none would be a good guess. The thing to consider with these very blurry lines that are not touching is that no matter what stage of the project in, you will have a real world impact, right? So there's always going to be something that you never planned for. And that's kind of be the guideline for today and for when we talk about project planning is that you have to try to account for everything, but there's still always going to be something that the real world imparts on your system, right? You deliver it to your client and they love it. And then 2 days later, one of their users says, hey, this program breaks on my phone, right? I've got an older Android or an older iPhone, or I'm colorblind, I can't actually see what's going on the screen, or it runs like crap, it breaks something. There's things that will come up even after delivery. And that gets into that maintenance phase and upkeep. Uncertainty will happen, the real world will happen. Adequately planning for this is what we're trying to basically get across here. So let's say that we are speccing out a project. And let me do something off screen here really quickly because I forgot to reset the slide from the last class. And that would be mildly annoying for you all if this popped up. So let me do this super quick. Reset results. Yes, yes. And clickety, clickety, clickety. And nothing ever happened. Oh my goodness. How did that happen? Told you it's been a day if you dropped in early. All right, so we're planning out a project, right? We're planning out people and time and costs and all of this stuff. What could be the reason that our estimates are inaccurate? So, what do you think would cause issues with their budgeting, with their planning, things of that nature? And while I wait for the answers to come trickling in here, we gotta get we got a friend today. It's very spooky in here. It's across. This is now a spooky class. All right, anybody have any guesses here? Do you see the slide? Okay, there we go. Sometimes I wonder if there's like a massive lag with Slido or not. I was looking over here in my streaming software and I was seeing the heading, not the actual questions. All right, interface between software and another client's machine. Okay, yeah, so good, interfaces. So if you're developing a system where the client can reach out and talk to it, whether it's an API that it has to get data from. Did I just lose answers? That was weird. What's going on here? I see 4 answers and then they disappeared. Okay, well, interfaces was a good one. I will talk to that. So maybe the data is invalid or it's not being parsed correctly. Yeah, I saw it like momentarily. I don't know what's going on with that. Let me go back here and refresh it. F in chat for Slido. RIP. That's weird. Please come back. Are we just frozen? It's supposed to be interference. Hey, interface is actually one of the correct answers, so good job. All right, present. Am I not logged into Slido or something? Should be fine. That's so weird. Wonder if it got like flagged somehow. Show immediately. Yeah. All right. Well, Okay, well, interference also works, right? So maybe there's some kind of a problem happening here. Let me stop clipping out of my headset here. On my side, Slido isn't showing more than those two. Yeah, this is all it's showing for me as well. Could be a technical glitch. So overtime conflicts. So basically we have people-related issues where we're expecting our employees to work crunch time, or there's conflicts between any member of our team or the requirements or anything. So yeah, sure. Overtime. What does overtime get us? It gives us unhappy employees, gives us possibly cut corners, possible oversight. So there's a lot of problems that could happen here, right? So for those of you that answered, good job. For those of you that answered and your thing didn't show up, good job as well. I caught them for like a half a second, at least. All right, so what are some things that we have? I'm gonna pop these all up on the screen because it'll be easier for you all to get what you need out of this. All right, so one of the key causes is also change requests, right? So if we have it built into our contract that we can actually take user feedback and apply it to our system, that means that our requirements have to change or our use cases have to change, our implementation has to change. So basically we have like a trickle back effect in a way, right? Where we have all these change requests coming in and we have to be adaptive and handle that. So could push everything back in our project, right? This whole software design process hinges on which particular workflow we're going down, right? If you're doing a waterfall type thing and you get a change request, it sends you all the way back to the top. If you're doing something more prototypey or agile, you can work that in, but you're still going to have to go back and reiterate or refine your models, for instance, right? That will take time and effort and money. We also might forget some things. So, oops, we had to add encryption to our online storefront. We forgot because maybe I was trained in the 90s to do websites and I'm coming back to it now and I forgot every website should be HTTPS when you're handling user data now, right? So it could be overlooked and we have to go back and figure that out. We also could have a lack of understanding in our requirements. So one of the reasons I'm having you all work on requirements for homework is to get used to being crystal clear in what you're trying to get across, right? This bullet here is the user's lack of understanding. So this is going to be your end user, but it could also be your developers. Could be anybody who has a stake in the project where if we are all interpreting the requirements differently, let's say there's 5 of us on the team, and each one of us has a different interpretation, we will move forward in our project differently, right? Nobody will be on the same page. And that's going to end up with a product which has to be fixed later on. Again, going back to that cost estimation effort. We might not analyze our everything correctly, right? So if we're developing estimates for time, cost, whatever effort we're estimating, basically, we could do a very lackadaisical estimation, right? We could do a very coarse-grained. So maybe it's going to take us 12 months or $1 million in funds to get this thing going. Or you could do a super deep dive into an estimation, do a more data-driven approach, get a very fine-grained estimate, but then it's possible it's too fine-grained and you don't have room for flexibility. Again, little column A, little column B here. There's always going to be trade-offs. Next one, lack of coordination. So this one's interesting. This is actually where you're taking it to a more group level, where maybe your developers and your analysts are on the same page, but you need system administrators, you need data administrators, maybe you need facilities managers on board, to work the mechanics of your system, assuming it's something real world, and they're just not coordinating appropriately. So, for example, let's say that I'm building an aircraft carrier, because that's one of our examples in our next modules, right? I'm building an aircraft. I have my mechanical engineers building the frame. I have my programmers developing the tracking software or the autopilot software. I have all of my analysts going nuts doing safety analysis and all that. So we have an airplane. Great. We don't have a facility to house it in until 3 months from now because it's currently being taken up by Boeing or somebody like that, right? So there are all these moving pieces which we have to consider, not just engineers, but facilities, staff, data analysts. They're basically, keep in mind, projects aren't just you and your manager, it's an entire team. We might also just not have a good way to actually do the estimation. So maybe we are using an antiquated model or a model that is incorrect for our domain. We'll be getting to what an estimate is in the next set of slides, just to let you know. Okay, so that is estimation, talking about uncertainty. Now we're going to talk about risks. So the first question is, what the heck is a risk, right? A risk might be, you might think of it as just something that happens that you have to deal with, right? Well, there's a little more to it than that. A risk is going to be an event that happens that is negative. All right, so the sentence right here is a pretty good definition. It is an unwanted event with negative consequences. So events will happen in a project, right? Whether it's good or bad, events will crop up over time. That's the real world influencing things. A risk is a special event that is bad. Again, intuitively, commonsensically, I guess it makes sense. But the point is that you're going to have to factor this into your projects. So how do we handle risk is the question. And there are 2 points that you can really kind of try to contextualize risk on. There's the impact and the probability that will happen. So I've got a little formula here. Excuse me. So the no. Well, that's why it was in here, because it kept falling off the door outside. And he just fell over there too. Bad skeleton. So the impact is basically how much will this affect your project, right? So what is the overall loss? This could be money, it could be time, it could be damage, could be physical problems like loss of life or, hurting somebody. So what is the actual impact of this risk? And then the probability is separate. So that's how likely is this thing to happen? And multiplying these together gives you the exposure. So what is the actual numeric value of risk? And I'm hand waving, I'm literally hand waving in front of you right here, right? These numbers are going to be domain specific, right? Your impact might be, you care about money. So how many millions of dollars can you push through on a conveyor line, right? You got parts being built, get 500 widgets built within the hour, that equates to dollars, right? So your impact if something goes wrong with that line will be money focused. Whereas if you're an auto manufacturer or you're developing an autonomous vehicle, impact is going to be human concerns like limbs, loss of life, injury, things of that nature. It's dependent, but this is kind of a generic high-level model here. And where this kind of comes into play, this figure is, I will say, this is not super helpful for you as an engineer, but this is a good visual if you wanted to convince somebody what the risks for your project are, okay? So on the left here, we have the probability that something will happen. On the top is its impact. If we have an event that will be catastrophic, right? So the Challenger exploding, the Therac leaking radiation all over your patient. This is a catastrophic problem. How likely is this to happen? This is where we start being the number crunchers. We try to take ourselves away from the equation and try to figure out, sorry, the human side of the equation. We figure out, okay, what is the positives and negatives of dealing with this particular risk? This is going to sound very non-human, I suppose. Think of, if any of you have seen Fight Club, there's that scene where he's detailing all the insurance trade-offs and all that if a plane goes down. But this is how sometimes you have to think in order to make decisions, unfortunately. We have to actually take risk and quantify it. So if something is catastrophic and it is extremely certain that it will happen, what is the overall effect to your system? What's going to be an extreme, horrible event, right? And if it's pretty certain that it's going to happen, you have to deal with it. However, if it's a negligible risk, maybe it's an annoyance for your user, it's pretty rare or unlikely that it happens. Maybe you just ignore it, or you subcontract it out to somebody else, or you do some base level of risk mitigation where we try to deal with it, right? So the point here is that we're trying to get information about risk to make decisions on what to do with it. And depending on how you feel about these things, because this can sound horribly inhumane, I suppose, but it's good to have data to back up your decisions later on. I will say that. Um, so let's talk about how we can actually manage risk and try to reduce risk. So there's kind of three high-level strategies. There can be more, depends on your situation, obviously. A lot of these things are situation dependent, right? So here's a few high-level ones. First thing you can do is avoid the risk. So we know that some particular risk will impact our system. What do you do about it? Well, let's not let it happen, okay? So our system, let's say we're speccing out an autonomous vehicle. The risk is that the autonomous vehicle makes the wrong decision and crashes into a wall. That would be an obvious risk. This is something you actually have to think about when you're developing these systems. Well, how do we avoid that? Well, let's make it non-autonomous. Let's make it semi-autonomous, where the user always has to have their hands on the wheel, so if they see they're going to hit the wall, they can correct. Then the other risk is people not paying attention and just assuming it's working, right? So that's your autopilot from Tesla problems there. But this is one thing you can do. You can change your system so that this risk is elsewhere, or it's not a problem for your system. Now, when I say change requirements, is that let's be sneaky and change them and nobody will know the better, know the wiser. That's your VW model for passing emissions tests. No, absolutely not. This is something that is agreed upon. Everybody's on board with this change. It is a necessity to make your product successful, right? It's not a underhanded thing. VW is based. VW did something very, very bad. And if you're not familiar with VW, look up their emissions testing scandal. It was not good, to say the least. So one of the other things you can do is transfer the risk. It kind of goes hand in hand with avoiding. So transferring means that another system will handle it. Or you buy insurance and hope the insurance writes off whatever went bad. This ideally would not be human related. It'd be more like monetary payouts, that kind of thing. But if you're transferring the risk, right, my system, my tea coffee making system has the, I can't even think of a good example for that, but basically, whatever my system is, it cannot be constructed to handle this risk. Okay? Whatever the specs are, I can't manage that. However, we can introduce another system to manage that, or we can subcontract something out, right? Somebody else will deal with it. Point is, we know it exists and we will handle it. Just this system we're building here doesn't do that, but it is handled somewhere else. But again, they're kind of similar ideas where you are not specifically handling that risk. The last one is to handle the risk, obviously. And this has kind of a nice benefit that you can trap it, right? So think of if you've ever done like trap codes where like if you've ever written a script or a program where you consume key presses so that like hitting buttons does nothing, even though it should be doing stuff. Basically, you are taking in this risk and you are mitigating it. You're dealing with it, right? The benefit here is that you can actually structure your program so that whenever this risk happens, it's not a problem anymore, right? Because you handle it. Your loss of life never happens because you follow appropriate coding procedures and safety constraints and all that, and you're human and your system is fine. The risk is there, however, you mitigate it. The point, though, is that there are multiple ways of handling risk. And again, keep in mind, we are not at the level of developer necessarily. We are at the decision maker level. We're the project managers, maybe the business leaders here. What do? An engineer brings you a problem, and you have to solve that problem, right? So let's say that I am one of your peons, right? So you're, I'm pointing at the camera. Obviously, I'm pointing at the classroom. Pretend each of you are project managers at your own company. Me, the intern, comes up to you and says, hey, I found this glitch in the system where we are leaking everybody's social security numbers to the web. And this is bad, right? This is really bad. So what do? The manager. You have to make a decision on how you're going to handle this risk. Okay, so there's 2 points here. One, there's data that's already out there, so you have to manage that. And then how do you plug the hole? So you can assume the risk where we patch our system, we fix things, we can transfer it where we bring in a contractor to build a patch over our server, however it's leaking. We have insurance maybe to help those people that had their data leaked and now they're doing the credit monitoring thing. I'm gonna guess you probably all have at least been contacted that your credit card was stolen. Here is free credit monitoring for a year. It's kind of that idea in a way. Or we can put our hands over our eyes and ears and pretend like it didn't happen. Maybe change our requirements saying that we don't expect our databases to be encrypted. Just random example there, right? But the point is that whatever decision you make, and again, you the manager, how do you back that up later on? Each of these is a viable answer, and how you handle it, is viable, honestly. But usually it's good to have some data to back up your decision. And this is where trying to quantify what risk is actually quite helpful. So risk exposure, if we go back a slide here, 2 slides, probability times the impact, right? So these are ethereal numbers which are specific to your problem. So what is the exposure? Wrong way. Before and after. And before and after is before and after whatever you did to reduce this risk, whether it's buy insurance, whether it's patch it, what have you. So it's going to be a subtractor here divided by the cost. And what this is going to get you, ideally, is a data point that you can use to back up your decision. No ethics or anything right here, right now, just here is some hard data for my decision. That's when you can start talking about what's ethical and what's not ethical, right? Maybe transferring the risk is horribly unethical, but it's cost effective. And then your manager says, hey, we can't afford $1 million recall, otherwise we go under. What do? This is where those ethical decisions come into play, and hopefully you've been trained to cope with that. I'm not saying go out and be unethical. I'm definitely not saying that, but keep in mind that hard decisions are up there if you start moving up the corporate ladder, I suppose. The intern or the developer has the easy job. They bring you the problems. It's your job to solve them. All right, so let's see if we can get Slido working here. So I've given you a list of things that can happen, right? Risks in a project. And I've given you the catastrophic, horrible, kind of evocative examples, right? Where this is where risk can lead you. Risks can be tiny. They can be inconsequential, but still something you have to deal with. So I'm curious what you think. What are some risks that you might have in a software project? And again, I gave you the catastrophic ones. They can be a lot smaller. They can be more process specific. They can be people specific. So I'm curious what you think risks would be. And I'm hoping that this is working because the last slide was not super helpful. So what do you all think? Maybe I should try this to see if it's working, because I have a phone. I can take a picture of a QR code. Hmm. Typical. Not having disabilities. Hey, that's a good one. Group conflict. Good. Yeah, so disability support risk could be your accessibility issues, right? You cut out half your user base because they can't read what you're doing or interact with it in some way. Absolutely. Yeah. At least it seems to be working from my end. Group conflicts. So this is a good one too, where groups could mean anything, right? It could be a client versus a developer, could be developer versus analyst, inter-team problems where you have maybe egos taking over, and I talk about these things as like common conflicts that you could have. The issue is that it leads to problems in the software, right? Corners being cut or problems overlooked or things of that nature. Employee quitting. Sure. So you have one key employee and they're gone all of a sudden. And the risk here is that, hey, we needed 3 months of development work out of that employee and they're gone. Now we have to bring one of you up to speed, which will take a month to learn the framework, time to be brought on. So yeah, absolutely. Improperly stored passwords, so we didn't hash things correctly. We didn't put it behind a firewall. Things got leaked, so we have data leakage. Absolutely. Yep. Good examples so far. So I've got a laundry list of some here in the next slide as well, and I'm going to pop them all up at once because some of them are related. To one of your points about group problems or people quitting, personnel shortfalls. So we don't have enough people to do X task. Again, that could risk our project timing or our budget. We might have unrealistic expectations. So the game developers crunch model where we have a year to build FIFA 2021. Let's just copy and paste it, and the press will have a field day with that. So schedules could be bad, budgets could be bad. Um, we could have development practices that are wrong. So maybe our functions that we created are actually the wrong ones. So we needed a radix sort, but we created a bubble sort because we thought that's what we needed. For a simple example. Or the interface is wrong, whether it's a GUI interface, whether it's an API interface, right? Some kind of an interface was, maybe it was uncertain at the requirements level and spec'd out wrong. Gold plating, I'm glad you asked that. Gold plating is a cheeky little term, I suppose, where let's get a pile of crap out of the backyard and put gold cover, plate it in gold, and then sell it. So basically, you have a system that is bad, but you put a nice coat of polish on top of it. So corner cutting would probably be a good analogy there. One of the things mentioned earlier, continuing stream of requirement changes. So this is where you might get a ton of feature requests, or you had a bad requirements analysis phase and you have to keep going back and changing things. When requirements keep changing, what does that impact? Everything, right? Implementation, models, testing, everything all ties back to requirements. We could have shortfalls in external things. So whether we have contractors doing tasks, whether we have modules that we're pulling in, which are not as feature rich as we thought they were. We could have licensing concerns. So basically external problems as well. Could also have just pure programming issues, right? Maybe performance in your system, could be performance by your employees, depending on how you want to look at it. We could be asking for something that is completely unachievable, either in terms of programming capability or the devices that are handling them, so on and so forth, right? So lots of risks can impact a project. It doesn't have to be like, I crashed the car into the wall because it thought it was blue sky instead of a wall that's painted blue. It could be just that we don't have enough people to work on the AI, which bubbles down further and further and further until it gets to catastrophic failure. One way I like to think of stuff like this is you kind of have a butterfly effect style thing where you screw something up when you hire somebody, and that just kind of percolates throughout the entire project, and something eventually expresses itself later on. So we have some risks. Anybody have any questions on this kind of stuff? So this is all, pretty high level, balancing risk with effort, talking about budgeting, things of that nature. What we're going to be getting into now is we're actually going to talk about how do we do this effort estimation, right? How do we actually try and figure it out? Again, just as a fair warning, it will be a little hand wavy. We're going to do some number crunching probably on Friday, but we're just trying to get a high level view of how these things would be done. And the reason we're not really going into details with this is that it can be very, very project specific. But having the idea of how you actually want to do the effort estimation is almost as important, right? Because it becomes plug value A into variable B. That is an exponential, which gives you 10 person months, right? So basically, think of it like we're trying to do generate a very complicated Excel spreadsheet at the end of the day, where you have formulas all kind of impacting each other, and the whole thing automatically updates. My poor USB cable. Gotta remember that I'm not in front of a whiteboard and I can't like slam my hands around without breaking a poor little wire. I think it's still okay. I got these headphones a couple years ago because they're Bluetooth, which I love, but Windows doesn't recognize it as a Bluetooth device without an extra dongle. So I've got this stupid cable plugged in here. All right, enough of my personal problems. So let's talk about actual project estimation here. So we're going to go through some of the high-level techniques. We'll talk about the Kokomo models, which are more algorithmic. We'll talk about earned value analysis, which you probably will only have heard of if you've ever had to do any project planning, but it's one way to basically look at estimation. So first things first, we have a handful of techniques that we can use to figure out cost. And again, if I were to ask you what cost was for a project, it's not necessarily money. It could be time. It could be materials. It could be people. Cost is a very nebulous notion, right? It could be effort. Just depends on how you're viewing the project. So first way we could do it is we could have something called expert judgment. This is where you bring in experts, right? So I can have my LinkedIn title, I'm an expert in effort estimation for Android projects or something like that. I'm not, because I really struggle with Android programming. It's more of a module issue, I think. But let's say that we bring in 10 experts, right? So we are building the next amazing autonomous vehicle. We bring in 10 experts. They might be consultants. They might be internal people who have worked on these projects before. They might be competitors that we're paying handsomely to come in to give their opinion, whatever it's going to be, right? These people know how to build a autonomous car. They know what has to go into it. They know how many people you need. They know what kind of activities have to be performed. They'll give you an estimate. Based on this project with your specifications that you're telling us, here's your use cases, or we read your use cases, we read your, maybe your business rules or your early requirements, and here's what we think this project will cost. It will take you a year, it'll take you 20 people, it'll take you $5 million in supporting fees, right? So let's scaffold everything up in terms of facilities, employees, staff, everybody, right? That's expert one. Expert two says, well, that makes sense, but I don't think it's going to take you that long and you can get away with a lot less people. Expert three has a different opinion. Expert four has a different opinion, right? So you're going to get an opinion-based estimation. And ideally, over time, this estimation would be refined. These experts may discuss their ideas and try to come to a common consensus. This is very opinion-based, right? So you have a judgment-based technique here. Something that's honestly good for an early analysis where you don't need to have super hard numbers, but you have to have a good idea of what's necessary. All right, so how do we figure this out? I mentioned looking at use cases, but maybe you don't have that at this point yet. What you can do is have something called a work breakdown structure, and I've got a picture here. Not strictly anything specific. I just pulled it up from Google Images, which is actually pointing to Wikipedia, which is pointing to what a work breakdown structure is, and they give an aircraft example. So let's build an aircraft, right? Okay, well, this might be for one of the defense contractors. So it might be like a Raytheon or something like that. Or what's the other one? It's multiple contractors, but it's for a fighter jet. Okay, so I'm going to bring in experts who have built these things before. They are going to understand that it's not just a plane that you're putting together, right? It's going to be all of the program managers, it's going to be the training materials, it's going to be any data that has to be crunched. Maybe you need industrial facilities to house the airplane while it's being built, while it's being maintained. So there's a whole laundry list of tasks that have to be done, right? And these are all still pretty high level. Application software. That is an entire aspect to this project, right? So these people will try to come to an agreement. Let's look at all these tasks. Okay, airframe, that'll take you 2 years to build. Propulsion, maybe we have some friends at the Jet Propulsion Laboratory, down at JPL who have the newest amazing jet engine they're working on. Or we have subcontractors who are great with air-to-air rockets, so let's bring them in. Point is that all of these tasks we're going to quantify. We're going to try to figure out how much effort each one of these tasks will take. And then we come to an agreement on overall project cost. Now, where we can kind of get into problems with this estimation, let's say that we assume that everything is going to be great. We're going to build our air vehicle. It's done in a year. However, oh crap, we forgot about housing the thing once it's built. So we don't actually have a facility to store a plane in until 3 years down the line because this space is being rented out by a competitor. That impacts your cost estimation. So we need an extra year to maybe build a facility on top of that, or we have to rent something else out. All these pieces get kind of jumbled together in one overall estimation, and this would be broken down too, right? You'd have numbers for each of these. Before I get into the next one, we're actually at the end of class, so does anybody have any questions on what we've been talking about, on the homework? Again, that's due Friday night. Anything at all, or otherwise I will let you all start zipping up your backpacks and move on to your next classroom. Virtual classroom, probably. But unless everything makes sense and we're good for today, I will see you all Friday. And are we going to get feedback on our UML diagrams? Yes. So the ones that are due Friday, you mean? Or the other ones? Sometimes I get, yeah, the ones due. Yeah, absolutely, I'll give you feedback. Let's try to remember that I didn't assign you something else. So it was just that one. Yeah, management. Oh, was it the in-class assignment you're asking about or the homework 3? Sorry, don't mean to hold you too long. Yeah, okay, yeah, definitely you'll get feedback. So you'll submit that Friday and I'll try to get you feedback as soon as possible. Because I'll want some of this information in your midterm stuff. So if you get feedback, you will, well, when you get feedback, you'll get it. Yep. All right, other than that, see you all Friday. Have a wonderful couple days where you don't have to deal with me. And I'll see you then. Bye, everybody.